Alright, so you guys are going to get a little bonus video here because I forgot to talk about this in some other videos. So this is, if you've already taken um, the weekly concept check, I apologize. I forgot to get this video. For those of you that take the class in the future, congratulations. It'll be there for you. So I totally forgot to talk about isomers. So these are molecules that have the same chemical formula but different structures. So they're a different shape, but they're the same pieces. They're just put together in a different way. So they have same molecular formula, and I'll give an example here in a second of this. But different structures. So they're different molecules, but they're just made out of the exact same pieces. Alright. So, as an example, you could have something like this, and something like this. Alright, so we've got a 1, 2, 3, 4, 5 main carbon chain with a side chain here. We got 1, 2, 3, 4, 5. So we got the same main chain, and we've got one carbon side chains, but they're on different carbons. So these are actually different molecules. I can't rotate this around and make it look like this. And so if we look at the molecular formula, well, I've got 1, 2, 3, 4, 5, 6. So it's C6. And then we got to be careful here. So we're going to work carefully. So this is going to have 3 H's, 3 H's, 2 H's, 2 H's, 2 H's, and 3 H's. So this is the trick we talked about before. I'm only seeing one bond on this carbon. It's making 4. So there's 3 missing. That means there's 3 hydrogens. And over here, actually, that is 1 hydrogen. So 3, 4, 7, 9, 11, 14. Now if I screw up, I'll have a different number over here because I know these are isomers. Alright, so I've got 1, 2, 3, 4, 5, 6 carbons. And then we just play the same game again. I know I have 3 hydrogens here because I only see 1 bond. I have 2 hydrogens here because I see 2. This guy up here has 3 because I only see 1 bond. But over here I've got 1, 2, 3 bonds. That's 1 hydrogen. 2 hydrogens. And 3 hydrogens. Alright, we added up 3, 5, 6, 9, 11, 14. Alright, looking good. So I at least screwed up the same way twice. And so these have the same molecular formula, but they're different compounds. And there's a few other examples we can do with this as well. Alright, so this line's not here. So this is cyclohexane. So this is 1, 2, 3, 4, 5, 6 carbons. And each of these carbons has 2 hydrogens because they each have 2 bonds. And so it's C6H12. And there's a number of different structures I can make. But I could have a chain. 1, 2, 3, 4, 5, 6. Okay. And as it's written now, these would not be isomers. This would have too many hydrogens. But if I just bring a double bond in there, now it's going to be 1, 2, 3, 4, 5, 6 carbons. And then I've got 3, 2, 1, 1, 2, 3. Yeah, this will work out. Always got to double check yourself when you're making examples up on the fly. Alright, and we just work our way through. So same trick as we've done before. Just count the number of bonds showing whatever's left to make 4, you use that. So 3, 5, 6, 7, 9, 12. So these are both geometric isomers, but they're very different structures. They have very different chemical behavior. And so you can say isomer, or sometimes you say geometric isomer. There's a few different kinds of isomers. And one that I want to specifically talk about as well are the cis-trans alkenes. Okay. So, what we have is a situation where you have a double bond, and maybe we write the Lewis structure for this, and it looks something like, or we'll make it a little, not full Lewis structure, but something similar. So there's a hydrogen up here, and there's a CH3 group over here, so that's what I'm doing. And now the CH3 group's going up, the hydrogen is going down, whereas over here, I've got CH3 groups going down both times. Okay. So these are this is a representation of the same molecule that I have down here. This is the same representation as here. And so what happens is so single bonds can rotate. But double bonds, it's like having two axles. They don't rotate. The whole molecule has to flip. And if the whole molecule flips, well, if I have two CH3 groups pointing down, I can flip it and get two pointing up. But what I can't do is flip one side and make it up and down. I can't do that. I have to move them both together. The double bond does not get to rotate. And so this molecule, looking like this, cannot simply have a bond rotate. I have to do chemistry. I have to break a bond to allow it to rotate and then reform the bond, and that is chemistry. So these are chemically different molecules. There's no physical process that's going to get me from here to here. And so if it goes across the double bond, if our carbon chain goes across that double bond, we call this the trans isomer. And if it's on the same side, it's the cis. So same as cis, trans is across. The way I always remember it is the transcontinental railroad. It goes across the continent, because I don't know, I'm a history nerd or something. I'm sure that will totally work for all of you. Another trick that someone showed is if you rotate this, it kind of looks like a C. Kind of looks like a C. So that works as well, C for cis. And then this one, it goes across. It goes across the double bond. So trans. So if you draw a carbon chain like we've been doing, and then you just start hashing in double bonds, you're hashing in a specific isomer, trans. This will be important later when we talk about fatty acids and lipids, things like that, because there's things like trans fats and cis fats. It has to do with the double bond. That's in an unsaturated fat. But for now, just be aware that these are different molecules. This is what trans looks like, this is what cis looks like. And we're going to practice a little bit more with isomers. But this is a very specific type of isomer. And you don't get this with alkanes because the single bond can rotate. And so, if you have something like this, it can rotate and do this. They can switch. They can switch back and forth. You get that double bond, it becomes like a pancake. You got to flip the whole thing. There's no spinning axle. And same with a triple bond. If you got a triple bond, you got to flip the whole thing. They don't rotate, and there's no up and down, right? It just goes straight out. So there's a whole other type of symmetry there as well. So just be aware. All right. So how do you know if something is an isomer? Well, we're going to play America's favorite game show. Are these isomers? All right, come on down, your next contestant. All right, so we got something like this and something like that. Are these isomers? What do we do? Well, what's the molecular formula? All right, well, I've got 1, 2, 3, 4 carbons, so this is going to be C4. I got 1, 2, 3, 4 carbons. Okay, maybe they're isomers. I'm not done, but I can't rule it out yet. Start with the carbons. Start with the easy part, because remember, hydrogens are tricky. I got 3 H's, 2 H's, 2 H's, 3 H's. So that is C4H10 when I add it up. Over here I've got 3, 3, 1, 3. Alright, that's C4H10. So, yes, these are isomers. Survey says these are isomers. Alright, so let's do another one. Are these isomers? Are these pair right here isomers? So we're just going to do the same trick again. I'm just going to count them up. I got 1, 2, I'm going to do the main chain. So 1, 2, 3, 4, and then 5, 6. I'll count the side chains last. C6. I got 6 carbons. Okay. Now I've got 1, 2, 3, 4, 5. So this is C5, and it's, you know, it's H whatever. But I don't need to go that far. I know I got 6 carbons, I got 5 carbons, and this is a no. These are not isomers. This is short a carbon. Okay. And so it's just, do they have the same molecular formula? So that cis trans thing, they had the same molecular formula, and it was just a specific scenario where they're a different molecule. So, you know, this has 4 carbons and 10 hydrogens. This has 4 carbons and 10 hydrogens, but they're put together in a different way. So this has a branch, it has a 3 carbon main chain with a branch, whereas this is just a 4 carbon main chain. No branching, no side chains. So you're getting different molecules, but you're getting them out of the exact same pieces. So it's like you have the same Lego pieces and you build one thing, you take it apart and you build another. That's what we have here. Alright, so you know, sorry this slipped my mind. I've been a little bit busy. I'm way up in an online poker tournament. Obviously, I don't need the money anymore, so you guys don't get my attention. That's definitely what's going on. Just kidding. Don't gamble. If you do, you got to do all that stuff like set a limit, whatever. If you ever really hate somebody, and you get like a magic genie, and you'd much rather just hurt that person than help yourself, what you do is you wish a gambling addiction on them, because that's like the worst addiction in the world. And you're going to say like, oh, well, what about a drug addiction? Well, you do spend your money and get something with a drug addiction. Like you get drugs. When you have a gambling addiction, you just spend your money and you get nothing. You just lose money. And you lose it way faster. And just like all the money you could ever get. Anything, any equity in your house, whatever, gone. Credit cards, gone. You know, future paychecks, you know, check cashing places, gone. Like, wipes you out. So watch out for that. So if you get that magic genie, and again, I recommend help yourself, but if you really just have to obliterate somebody, here's some professional advice. That's how you do it. Alright, so again, sorry about missing this. Hopefully I get this to you in time for you to digest it for the exam. And if you have any questions, just let me know. Someone was actually had pointed this out. Someone pointed out in the email that I hadn't really covered this, and so thank you for pointing that out. And if anything like that happens in the future, just let me know. I'm not above, you know, taking my medicine and making a video, going back and making a video for a topic I thought I'd already wrapped up. I'd rather, you know, do whatever I can to help you guys. So yeah, in the future, if it happens again, hopefully it doesn't, but if it does, just let me know.